So now let's talk about Mesomeric effect. What is Mesomeric effect? The resonance of any group is known as Mesomeric effect, and that group is known as Mesomeric group. Okay, so if it is a resonance, suppose we have a group CH2 double one CH and X, it is a group. Okay, so when X it is a group, so that effect of that group is known as mesomeric effect. So the resonance of any group is known as mesomeric effect, and the group is known as mesomeric group. Okay, so this group is known as mesomeric group. Mesomeric group. Now, whenever we have seen p-pi resonance, that is known as mesomeric effect, and every mesomeric effect is a resonance effect. Okay, so we know every mesomeric effect is resonance, but vice versa is not true. Every mesomeric, when there is a group, like if we have a group NO2, then it is a mesomeric effect. But we have when in a compound like Cl in there, in particular this example, if we have so that we will not consider as a mesomeric group. Okay, we will consider it as a mesomeric group. Okay, so whenever there is a compound like NO2, then it is known as mesomeric effect. Okay, so every mesomeric effect is resonance, but vice versa is not true. So p-pi resonance is known as mesomeric effect. Okay, so if we can also say it p-pi resonance, whenever we have p-pi resonance, it is known as mesomeric group. Okay, mesomeric effect. So there were a lot of conjugation structure was there, but whenever we consider p-pi resonance, it is a p orbital, and it is a p orbital. So p-pi resonance is known as mesomeric group specifically. Okay, specifically in this type of conjugation, whenever we have a X compound, when it is in the resonance, so we call it as a mesomeric effect, because it has a p-pi resonance. But other compounds were there like CH2 plus and is resonance with some X compound. So then if that is not a p-pi, then we will not call it as a mesomeric effect. Okay, so mesomeric effect is mainly divided into two types. One is plus M, electron donating, and one is minus M. So electron donating tendency via resonance, it is electron donating tendency via resonance, and it is electron withdrawing tendency electron withdrawing tendency via resonance. So we have two type of group like plus M and minus M. So it is similar like plus I and minus I effect. Whatever we saw about plus I effect, and it is minus I effect. So like it is again a permanent effect. It is again a permanent effect. Okay, so let's see an example. We have a CH2 double one CH2 and a group is attached Y. Okay, it is a lone pair. So when that is donating, when it is donating electron outside the system, if we see Y as a system, okay, because we know we are checking the resonance of this group. Okay, so if we consider Y as a system, is Y is donating some electron. If Y is donating some electron, then we consider it as a plus M group. Okay, we know whenever someone donates, we consider plus M, and if someone accepts, like if we take an example, CH2 double one CH2 and it has a one NO2, N double one O and O. Okay, NO2. So if this bond goes this side and this bond goes this side, this is a resonance. If again we consider it as a system, so it is accepting electron. So whenever something accept, we consider it as a minus M group. So just see when the terminal carbon attached with some group, consider that as a system. If it is donating electron, then it is a plus M group. If the electron is coming inside that system from that carbon chain, then you consider it as a minus M group. So let's consider, let's take some more example. If we talk about plus M group, if we talk about plus M group, like if we take an example of halogen, if we take an example of halogen X, okay, if it is donating electron, so it will be X minus, okay, again if we see X minus, again if it donates the electron, then it is minus charge. Again if we rotate this resonance again, it is negative charge here. Again if we donate that electron in our above side, it is negative charge here. So we consider how many resonating structure we have drawn. Actually there are 1, 2, 3, 4 resonating structures are there. And again if you consider this as a system, so it is donating electron, that's why it is considered a plus M group. Okay, now it is considered a plus M group. Now if we see again one more group, minus M, if we see the example of minus M group, if we see the example of minus M group, so in minus M group, let's consider benzaldehyde. Now if we consider benzaldehyde as a system, so this will accept electron. Okay, that's how it will accept electron. Okay, so here it will be generate a positive charge. So minus M will generate a positive charge and plus M will generate a negative charge. So when we talk about plus M, actually it is donating electrons to the system, to the benzene system. So that's why it is called activating group. That's why it is called activating group. Okay, because it is donating electron to the benzene ring and it is taking electron to the benzene ring, then that's why it is called deactivating group. Deactivating group. So it is called activating group because it is donating electron to the system and it is taking electron to the system. So it is activating group. These are called ring activating group and these are called ring deactivating group. Okay, every minus M group takes electron from the system, so it actually decreases the electron charge density on the benzene ring. So it is called ring deactivating group. It is called ring activating group.